Hello, I'm Jonathan Sheikh Miller, Content and PR Lead, and today I'm joined by Gerry Martinez, Sales Account Manager, Drilling Solutions, and Brett Robinson, Senior Business Development Manager from the Gilmore team, to talk about the evolution and the distinct advantages of the recently launched GEN2 Pressure Regulator series. Thank you for joining me today, guys.
Hey, thanks for having us, Jonathan.
Thank you.
No problem. Let's start with a subject that you've talked about publicly before, Brett, across a number of media platforms, and that's the wider methodology behind the development of the Gilmore GEN2 series of products.
Absolutely, thank you. Great question. So Gilmore was founded back in 1963, and over the last 58 years that we've been around, we've come out with some of the industry's first offshore shear seal, relief valves, regulators, shuttle valves, and many more. Many of these legacy products are antiquated and really needed improvement for the reliability Gilmore desired in our products today. So at the onset of the downturn, we made major investments to our engineering and R&D teams, creating Gen 2 upgrades of our legacy products. These upgrades included starting with just using customer feedback and eliminating failure modes found in field issues. That reporting back to us was so critical in better understanding how our valves were being used and what we could do to design better products for higher reliability in the field. We saw a need for standardization to improve lead times and costs, taking all these different variances of singular products and slimming them down while still addressing all the applications out there. We needed to increase the cycle life of our product by 2.5 times above our legacy offering. So rather than the standard API 16D 1000 cycles that are expected, we've gone to 2,500 cycles. We've upgraded materials of construction to all corrosion-resistant alloys to ensure solid subsea and topside use. We've introduced new technologies to reduce costs associated with the selection of exotic materials, trying to refine and reduce the amount of material needed while still giving the resiliency of that kind of sealing. We've eliminated errors in the assembly of the products, trying to look at common designs and how we can eliminate special tooling and make assembly and maintenance of the product easier. We've provided ease of field serviceability with that. We've created suitable support documentation, manuals, PIBs, etc., that help provide our end users and our own technicians with the ability to easily and repeatedly rebuild and assemble and test these valves as they come off the line. And finally, we've published qualification flow data so that our customers have a better understanding and know like for like how the legacy product versus our new product work, so they can bring these in and drop them in without concerns of does it meet my needs. Then we also have ensured that all of our Gen 2 products, that they fit the same exact envelope for those connection ports of the legacy products, so that they're simply drop-in replacements and you're not needing to bring out service crews or do any piping or tubing work yourself.
Some really great detail there, describing the background to the Gen 2 series. So Gerry, Brett's just outlined how the Gen 2 series has taken shape, and a key driver of this has been design improvements, the use of more resilient and durable compounds. So what are the specific core strengths of the new Gen 2 pressure regulators?
Thank you, Jonathan. So a regulator is a dynamic valve that is set to control pressure at a given point. At all times, it's sensing pressure, both relieving excess or compensating for pressure drops. This very nature of the regulator makes it a high cycle, high wear piece of equipment in a control system. Specifically for the regulators, knowing that it's high wear and high cycles, we started with what knew was going to be a great result, which was switching to tungsten carbide shear seal components. Now, this technology we understood and knew worked about 4 to 5 times better than the legacy material, but we knew it was cost prohibitive. So we went through great lengths at optimizing the amount of tungsten carbide material that is used, and we were able to apply that to the regulators. In terms of the regulator being dynamic, there are a lot of parts that see wear in this manner. So one area that we improved was the seal carrier and the plunger. As these parts reciprocate up and down, they see higher wear. So we put great amount of detail in how well guided these were, and we added wear bands to accommodate for this. These also serve a dual feature of giving some damping in the regulator. As the valve reacts to system pressure changes from other valves opening and closing, these can create a lot of dynamic um, oscillations in the system, and the valve can sometimes suffer from that. So we build in some damping internally to the valve to reduce that, to greatly reduce the amount of cycles that the valve sees when it goes into a dynamic mode. A lot of the parts that had perhaps too many degrees of freedom were tightened up a little bit. We bolted the plunger guide onto the sensing piston to prevent binding and to reduce friction internally in the valve, along with changing the springs to a corrosion resistant material. Like Brett mentioned, we improved the guidance inside of the spring chamber as well. Anywhere where we had reciprocating dynamic seals, we've upgraded from your regular O-ring to a T-seal. This goes a long way against preventing extrusion or spiral wound failures in the seals. And overall, wherever we could, we put dual backup rings because we had identified that as an issue with personnel rebuilding the valves, especially out in the field, where the backup ring would get installed on the wrong side of the pressure side. And thus, by adding two and making it symmetrical, we eliminate that failure mode due to operator error. And like Brett mentioned, just overall material improvement to make the valve more corrosion resistant, and using some known materials to have bearing properties to reduce the friction in the valve.
Well, you described some really wide-ranging upgrades there, Jerry, to these products. And from what you describe, it sounds as that Gilmore has designed a product that has tried and tested resilience, durability, retains optimal performance in harsh control system environments. And within drilling operations, we're talking about some seriously hostile environments. You've got debris-laden fluids. So how do these various design strengths that you've just outlined, how do they advantage a prospective Gilmore customer?
Right. So these regulators are both used on topside equipment as well as subsea equipment. In the subsea environment, you're seeing high pressure just from the atmosphere and high corrosion environments. The regulators were on a 1-year service interval, and our goal has been to make our valves serviceable to a 5-year service interval that ties in with the major service interval of a rig. The other thing was the known behavior that we've established during our extensive testing. We've done really well at documenting and baselining how the valve works under flow, under different pressure conditions, and at different set points. So this allows us to understand the behavior of the valve very well. This lets us relay that information to our customers, how they can expect the valve to work. And if for some reason the valve is deviating from these baseline numbers, it gives us ideas and it gives us data points that we can say, hey, we may need to look at this valve at your next opportunity. Instead of waiting for the valve to completely break down, we have that known baseline performance that we understand. We let our customers know, and they can build that into their program, as well as the variation of valves that we've done. Not only did we do a manual spring set point version of the valve, we have a hydraulic pilot that has a low sensitivity to reaction, which we call deadband, as a very low deadband. We have a air pneumatically controlled valve that you can remotely set the set points to the valve.
Well, thank you for that, Jerry. Some real core details there, and some real strong advantages for potential customers. Finally, Brett, there's been an increasing amount of attention on ESG policies and strategies in the media across a number of platforms. And many energy companies, Gilmore included, have taken a good detailed look at how they can make a change or an adaptation to how they do things to reduce their waste and maybe their carbon footprints, of course. Listening to what Jerry has just mentioned, it would seem the Gen 2 series, the wider series, and the new regulators included within that, they could play a notable part in this.
That's absolutely correct, Jonathan. So ESG, standing for environmental, social, and governance. As part of our Gen 2 development, we took a look across all three of those points and said, how are the developments and the improvements we're making here, how can that help our clients with their ESG and our own? So starting with environmental, we took a look at that cost of ownership. So by extending the service intervals required for our Gen 2 products to that 2.5 times life cycle, you're reducing repair kits, the amount that you're needing to ship back and forth to the rig. So reducing shipping and the amount of raw materials you're having to order along, and that transportation cost and that carbon footprint is reduced. Looking at the enhanced materials and improved designs to eliminate failure modes, that's really critical to our clientele, ensuring that the product's not failing, you're not having to pull a stack, you're not having to waste that energy, that time, that labor in having to deal with a valve failure. And finally, the reduced machining with the standardization we've done by standardizing common components and adding that to the technology enhancements. It reduces the costly materials to our clients, reducing their prices, reducing the amount of waste we have with having to make 50 different variations of the same part that we have now in the Gen 2. Next, you have the social aspect of it. And the critical part there was us listening to the voice of our customers, using that feedback and design to design failure modes out of the products, ensuring that we are getting that feedback, we're listening to it, we're reacting by changing the designs for the better. We've improved our website with downloadable resources like PIDs and full product catalogs, and post daily on LinkedIn, sharing our day-to-day updates and what we're doing to better the industry. And finally, we've designed human error factors out of our designs, trying to eliminate by improving the manuals we provide, but also preventing special tooling and making it easier so maintenance failures don't occur. And then on the governance side, we've documented testing above API requirements, meeting the IEDC Advanced Rig Technology recommendation for BOP control valves. And we actually helped develop that with a consortium of other valve manufacturers, drillers, and operators alike. We provide full assembly, test, and installation manuals for each of our Gen 2 products to ensure our clients better understand how to operate them and maintain them to reduce errors in any kind of maintenance programming they have.
Well, that's really great feedback. Guys, thank you so much for an interesting take on these new pressure regulators and how they can really make a difference in drilling operations. The new Gen 2 pressure regulator catalog and product sheets are available at gilmore.com. Thank you for watching.
Thank you.
Thank you.